गुड मॉर्निंग स्टूडेंट। आज ये मेरा पहला वीडियो है एंड आई होप दैट यू विल गेट क्लियर कॉन्सेप्ट्स of the Mayer's formula for the gases. This chapter is related with the kinetic theory of the gases. Okay, the main formula tells Cp minus Cv equal to R. Now before proving this one, we have to understand what is Cp and Cv. Before that, we have to find out what exactly the specific heat is to be. So as we know specific heat, first of all we have to clear the concept of specific heat, or sometimes we say it specific heat capacity. So first of all we have to know the specific heat capacity, or say specific heat. Okay, so as we know, when the heat is supplied to a body or an object, if Q dash heat is supplied, right? For example, since most of the time students get confused about the heat supply and heat absorbed. So one thing we must clear in the mind, the heat supplied is not important as much as heat absorbed by the body. Heat absorbed by the body. So कभी कभी क्वेश्चन में देता है हीट सप्लाइड दिस वन। अगर हीट एब्जॉर्ब की क्वांटिटी नहीं देती है तो हम एज्यूम कर लेते हैं कि जो हीट सप्लाई हुआ है वो ऑब्जेक्ट ने एब्जॉर्ब कर लिया। सपोज दिस इज़ द ऑब्जेक्ट, दिस वन इज़ द ऑब्जेक्ट। ओके, दिस ऑब्जेक्ट इट इज़ ऑफ मास m। अगर इसको Q डैश सप्लाई करते हैं हीट, ओके, दिस इज द सप्लाइड हीट फ्रॉम द सम आउटर सोर्सेज। ओके, इफ द हीट इज एब्जॉर्ब, हाउ मच? दिस इज ए Q heat absorbed by the object. Then what exactly the statement is that the heat absorbed is directly proportional to the mass of the object. Okay, absorbed heat is directly proportional to the change in temperature. If initial temperature is T, if initial temperature of object, if initial temperature of the object is T, after absorbing the Q heat, temperature become T plus delta T. So how much changes in temperature taken place? That is a delta T due to the absorb of heat Q. Hence Q equal to mc delta T. It means we can say the heat supplied and the heat absorbed from the supplied heat by the object is directly proportional to the mass of that object which absorbed the heat. And as we know, when we supply the heat to any object, whether it is a solid, liquid or gases, temperature rises. The nature of the heat is to rise the temperature. So one concept must be clear. Whenever there is a heat supplied to any object, temperature rises. Okay. So heat absorbed is directly proportional to the change in temperature. If initial the temperature of object is T, after absorbing the Q heat, there is a change in delta T, T plus delta T, then this is 1. And to remove the proportionality concept, proportionality, we add a constant. This constant C is known as specific heat or specific heat capacity. Okay. Now we have to go through what exactly the specific heat is to be. So once we try to define it, if M is 1 and delta T is 1, then Q is equal to C. It means we can say the specific heat of an object. This is for what? This is for the object. Okay. अगेन ये कन्फ्यूजन्स को आपको दूर करना है. ये जो C होता है वो किसका होता है? वो ऑब्जेक्ट का होता है. दैट डिपेंड ऑन टू द नेचर ऑफ द मटेरियल ऑफ द ऑब्जेक्ट. ओके. सो what exactly the specific heat? Specific heat is the nature of any material or substance or object. Okay, now this portion is clear. If M is a 1, delta, there is a change in 1, then Q is equal to C. Okay, so we can define the specific heat by this way. To raise the temperature 1 degree centigrade of 1 kg mass is known as specific heat capacity. Now, again, for the solid and liquid, the C is same. Okay, C is not going to be, C is different, that depend on the material, but that Q equal to MC delta T we have to study for solid and liquid. Okay, why not for the gas? So now we have to come, why not for the gas? गैस में what exactly is to be? गैस में दो तरह से होता. हीट एब्जॉर्ब इक्वल टू एन सी पी डेल्टा टी and Q is again n C V delta T. It means in the gas there is a two specific heat capacity we have to study. Now Cp is equal to Q upon n delta T and Cv is equal to Q upon n delta T. Okay, now this is clear. Why we are saying, if in gas what happened, if there is a no heat supply, if there is a no heat supply, it means Q is equal to 0, then C is equal to 0. If in a gas, if temperature drop to 0, then C is equal to infinite. It means we can say in the gas, the value of the specific heat varied from 0 to infinite, right? Now, again we are coming with this Cp. Cp is nothing but it is, since here N we are study is in the form of mole. What exactly the N is in the gas is the number of moles. So we can say in the gas Cp and Cv is nothing but it is a specific heat capacity or specific heat of the gas at constant pressure, right? Cv, it is a specific heat or specific heat capacity of gas at constant value. Now, concluding the point, in the gas, specific heat capacity vary from 0 to infinite. Okay, but in solid and liquid, it is a very simple. The gas supply and the absorb of the gas, if absorbed quantity of the heat is q, then q is directly proportional to the mass of the object. Q is directly proportional to the change in temperature in the object after absorbing the q heat. C is the constant. It is known as the specific heat capacity of the object or the substance or the material. Okay, now it is clear. So m is the mass. Simply we are saying specific heat capacity. But if in place of the mass, if it is to be n, then this specific heat is known as the molar specific heat capacity. I hope the concept of the specific heat has been clear. Now, once we are going to prove the Cp minus Cv equal to R, where the Cp is the specific heat capacity or specific heat at constant pressure, and Cv is the specific heat, or we can say specific heat capacity at constant volume. R is the gas constant. So before proving the Mayer's formula, two concepts we have to keep in our mind. First, what exactly it is? First law of thermodynamics. What exactly the first law of thermodynamics is saying? It is saying if we supply the Q heat, this is the Q heat, but this Q is not the supply heat, but it is the quantity of heat which has been absorbed by the system or by the object. So what exactly the first law of thermodynamics is saying? If heat supply and absorbed heat is Q, then it is going to be used in two forms. Since the first law of thermodynamics is nothing but it is a law of conservation of energy. Q heat is utilized in two ways. First, it increases the internal energy of the gas. And what exactly the internal energy of the gas? Again we have to come through that what exactly it is. Whenever heat is absorbed by the system or by the material, its molecular speed increase. In a gas, as we know, the internal energy is nothing but it is a kinetic energy of the molecules. Now the question arises, which kinetic energy is? Whether it is a translational kinetic energy, or whether it is a rotational kinetic energy, or whether it is the addition of the translational kinetic energy and plus rotational kinetic energy. Now there are three options. First options, the internal energy of the gas is first translational kinetic energy, second rotational kinetic energy, third total kinetic energy, fourth none of these. So once we prove P equal to 1 upon 3 rho V square, where rho is the density of the gas molecules, and V, here is important, V square is nothing but it is a average or mean square velocity of the gas molecules. So मेरे प्यारे स्टूडेंट, पहले आप आइडियल गैस में प्रेशर्स जो क्रिएट होता उसको प्रूव ज़रूर करिएगा। तो आप देखेंगे जो ये एवरेज मीन स्क्वायर वेलोसिटी है या जो मीन स्क्वायर वेलोसिटी है वो ट्रांसलेशनल मोमेंट की वजह से ही आया हुआ है। दैट इज़ जस्ट बिकॉज ऑफ द ट्रांसलेशनल मोमेंटम ऑफ ए गैस मॉलिक्यूल्स। उसी को हम एवरेज निकाल लेते हैं तो पूरे मॉलिक्यूल्स का एक एवरेज स्पीड निकल जाता है, जिसे हम स्क्वायर में लेते हैं। ओके, नाउ द कॉन्सेप्ट इज क्लियर। सो इंटरनल एनर्जी ऑफ ए गैस is due to the translational kinetic energy. No role of rotational kinetic energy, and not it is a total kinetic energy. Now the concept is clear. Once we, if somebody will ask, if the question is there, internal energy depend on which energy, so it is a totally on kinetic energy. Why we are not adding the potential energy? The reason is very much clear. Since in ideal gas theory हम लोगों ने एक चीज़ पढ़ा हुआ था कि जो आइडियल गैस होते हैं उनके मॉलिक्यूल्स के बीच में अट्रैक्शन फोर्स जो होता है वो नेगलेक्ट हो जाता है, यानी देयर इज ए नो अट्रैक्शन फोर्स बिटवीन द मॉलिक्यूल्स, henceforth there is a no potential energy. Concept is clear. So the heat absorbed by the system, if the Q heat is absorbed by the system, so one part is to increase the internal energy and second part is to do the work done. Work done किस में के लिए होता है गैस में? When there is a changes in volume. If we go through the isochoric process, there is a no change in volume, hence work done is zero. So sometimes there is a question arises, why Cp is greater than Cv? So we should understand at the Cv means at constant volume. Constant volume means there is a no work done, W equal to 0. So all the heat supplied is going to be change in internal energy. And internal energy is nothing but it is a kinetic energy. So once the kinetic energy increases, there will be the increase in temperature. Hence Cv, we come through that, Cv is this one. If this temperature is going to be increase more, then the value of Cv is going to be lesser. अगर ये डेल्टा टी कम चेंज होता है तो Cp क्या होगा? बढ़ेगा. That why Cp is greater than Cv. Okay, and this is constant Cp upon Cv. Okay, in Poisson's law we know the Poisson's law, this one is the constant. Okay, ये कांस्टेंट हम लोगों ने पढ़ा हुआ था पॉइसन्स लॉ में फॉर द आइडियल गैस. इसमें इन आइडियल गैस वेन एवर वी कम थ्रू द आइडियल गैस देयर मस्ट बी टू इक्वेशंस इन द माइंड. फर्स्ट आइडियल गैस इक्वेशंस, एज वी नो द आइडियल गैस इक्वेशन इज नथिंग बट PV इक्वल टू nRT. Okay, now we are coming on to the topic Cp minus Cv equal to R. Same thing. For 1 mole of gas Q equal to Cp into delta T. n की वैल्यू 1 रखने पे Cp इक्वल टू Q अपॉन डेल्टा T. सेम हीट Q सप्लाइड और एब्जॉर्ब्ड at constant volume, then for 1 mole Cv equal to the, from first law, now put the value of that. Okay, at constant pressure and constant volume पे हमने हीट सप्लाई किया होता, Q की जगह हमने ये रख दिया, इसकी वैल्यू हमारे पास ये आ गई, ये हमने रख दिया. वर्क डन क्या हो गया? चेंज इन वॉल्यूम डेल्टा V हुआ है तो वर्क डन इज इट. नाउ वी पुट द वैल्यू ऑफ दैट, देन Cp माइनस Cv इक्वल टू P डेल्टा V अपॉन डेल्टा T. एज वी नो फ्रॉम द गैस इक्वेशन PV इक्वल टू nRT, सिंस वी आर कंसिडरिंग 1 mole, henceforth R is equal to PV upon T. So Cp minus Cv equal to R. Now this concept is clear, and why the Cp is greater than Cv, it has been cleared by this way. Okay, I hope the concept will be clear to all of students. Thank you.